Hello, and we're taking a look at 1.4 web technologies, client and server-side processing. Now, surprisingly enough, this PowerPoint is not going to be 140 slides long. I know, incredible. Now, we're going to be taking a look at what client and server-side processing is, what the advantages of and disadvantages of both are, what languages are associated with each, and then we're also going to be taking a look at Fin and FIC client-side processing. So to start off with, we're going to look at the relationship between the server and client. Now, as a classic one, because Richard really loves it, we're going to be looking at the EasyJet website. Reason being is that it's got dynamic content on it, and it also allows you to do web queries such as finding specific flights. Now we're going to be taking a look at this input box here, which allows us to send data to the server, say with certain parameters. For example, I want to fly from London Gatwick to Cyprus Larnaca Airport, departing on the 1st of April. Now, if we start, we're going to be taking a look at what the relationship between the client and server is. So the client is basically your computer and your browser. You input into that box that you want to see tickets for flights on the 1st of April going from London to Cyprus. That request is then sent to the server, and it receives it, and then it will run an SQL statement basically saying select all of the flights from the flights table that have the departure airport being Gatwick and destination being Larnaca and the arrival being on the 1st of April. That is server-side processing. The reason being is that stuff like SQL, where it is then going to build the web page using the information that is retrieved, such as all of the records that it has for those parameters, i.e. from Gatwick to Cyprus on the 1st of April. All of that information is then going to be placed into a web page. Building that web page uses stuff like PHP, and getting that information uses SQL. And that is server-side processing, where it will then send that web page back to the client to be used. Now, this is what it looks like when the client receives it on their browser, and what you'll notice is that the browser has then gone and taken that information and basically built it and displayed it on the screen using that HTML and that CSS. Now, if we take a look at this specific box, this is an entry for one of the tickets. Now, if we look at that small slip of information there, we can see that it currently says 11 people currently looking. However, if you sit on that website for a few seconds, it was then going to slowly fade to a different message. Last booked 29 minutes ago. As you can see, it fades between the two on the actual website itself. And that is not being done by the server. You are not sending constant requests every 5 seconds saying, can you update this one single tiny message on the screen. Instead, that is being done by the client, because the server sent that information and the client has basically said, right, I'm going to change this message every few seconds. That is client-side processing. And if you were to do that on the server side, it would be very inefficient. You'd use a lot of bandwidth and it'd be very wasteful of resources. So if we take a look at the actual languages we use for both, client-side processing involves JavaScript, CSS and HTML. Now JavaScript is used for stuff like buttons, input validation, processing, a lot of stuff really. Now CSS and HTML aren't strictly actually languages, they're scripting languages. However, both are executed on the client's computer on the browser. Now the HTML actually sends the content and the body of what the website is, and the CSS then stylizes it. The browser, which is a client, is responsible for applying that CSS and processing it and applying it to that HTML to make it look pretty. Server-side processing in this instance would involve SQL, where we have sent that information in our box to say, right, I want these set of flights. It has then selected those flights from the database using SQL. PHP has then taken that information and constructed a web page out of it. And as another example, Python, using things like the Django or Flask web framework, that is then responsible for handling the actual messaging back and forth over the network using the ISO model or using the TCP/IP protocol. And so that is a quick idea of what languages are used. Now, if we take a look at the uses, advantages and disadvantages of the two, a lot of the generic uses kind of meld in with the advantages and disadvantages, which is why they're both on just this one table. Now, when we look at the client side, if we use more client-side processing, we reduce server load, which is always a good thing because server time is really important. We also reduce bandwidth usage. Like I said, we're not sending a request every 5 seconds to update that tiny slip of text on the web page. The client side also provides initial validation. However, you never want to use exclusively client-side validation. Now, the reason you'd want initial validation is because if the user tries to enter an email address that's invalid, it basically gives the user a quick idea of the fact that they've sent it improperly, and also it means that the browser isn't going to waste its time trying to send that information across the internet and therefore waste bandwidth. And finally, it also makes websites more responsive. Now, the advantage of server side is that processes are hidden from the user, which provides better security. It allows you to query and update databases. So, for example, that thing where we actually looked up certain specific flights wouldn't be possible on the client side. And servers also deal with much more complex operations, and they allow for the further validation, for example, the actual sterilization of input, removing any SQL, things like that. Now, for the disadvantages of client side, we're going to be looking at the fact that validation still requires server side processing, because whilst the client side is great, it can't do everything. It can't store the local information, and the validation, no matter what you do on the server on the client side, you still have to redo on the server. The reason being is that you might input a valid email address because it has a part before the @ and that symbol and part after the @ symbol. However, if you then put SQL into that post @ symbol, or if you make a modification to your browser that allows you to access and change the JavaScript so that that validation is no longer done, when you send that to the server, if you don't then continue to do further validation at the server side, that SQL injection is going to get into your website and can cause havoc. Now, the disadvantage of server side is that, for one, it does increase bandwidth usage. However, that's kind of implicit, because when you ask for a website to be sent to you, you increase the bandwidth being used. It's just how the internet works. However, for superfluous requests, such as asking for that one slip of text to be changed, that wouldn't be sensible. Server-side processing is also more complex. However, again, that's just by nature, trying to fetch all those that information and work with different frameworks. And then potential security issues during transmission, because again, you could always have packet sniffers. However, in the day of encryption, stuff like that, that's not really all that likely. Now we're going to take a look at thin versus thick client computing, and this is actually all of this is indeed part of the actual A-level and stuff you need to know. So when we're looking at thickness, this is a comparison of how much processing the client does compared to how much the server it is connected to does, and as well as processing and storage. Now, the more processing and storage that the server is responsible for, the thinner that makes a client. A client with a lot of processing power and a lot of local storage would be classed as a thick client. Now, very thin clients only require very little processing and very little storage capability, and therefore possibly something for the user to interact with, and that could be anything like a keyboard or a touchscreen. And the very thin clients are simply known as dumb terminals. Now, for an example of thin clients, you could go into McDonald's and you'll find those large terminals. Those large terminals do not process the order there and then. All they are responsible for is showing you images of the food, the prices, and having a touch screen display, as well as a PIN input post so you can then pay for the item. All of the actual order processing, things like that, is then sent to possibly a computer in the back of the restaurant. I mean, if you can really call McDonald's a restaurant. And then that will then process it and show the people on the other side of the counter what you've ordered and how much you're spending. Now, the advantages of thin and thick clients are as follows. So a thin client, for one, is very easy to set up, maintain, and just add new network terminals, because by nature, if you were to just add in a new screen, for example, it should just work. Now, software updates are auto-distributed terminals. Again, this is looking at the the different web topologies and making sure you understand how they're all differently interconnected. And for a thin client, that means that software updates are automatically distributed. And also, it's more secure with a lot of thin clients because the data is stored centrally. The advantage of thick clients means that you can have more robust and more reliable, greater uptime, because the computers can operate freely on their own. So if you consider a thin client to be something like those McDonald's terminals, a thick client could be simply something such as your own computer at home, because it's able to do things on its own without a server. However, if you then want to go onto YouTube, you would have to then connect to YouTube servers. And also, thick clients are better for more demanding tasks, such as running Photoshop or Adobe Premiere. Thin clients have the disadvantage of being more reliant on the server, and so if the server goes down, so does that terminal. It requires expensive server hardware because all the processing is being done by the server, and the server demand and bandwidth are of course going to be higher because you're sending more traffic over the network. Now, for thick disadvantages, for one, a thick computer is more expensive. Obviously, you're going to be spending a lot more money on a GTX 3090 than if you were to just buy a £200 Chromebook. Network admin time is increased because you would then manually have to install all the updates, etc. on your own computer. However, of course, there are ways of getting around that. But again, this is A-level computer science. We need to look at it in a very black and white fashion. And then integrity issues could happen with distributed data. Because if you've got the same data across all these different things, you need to be looking at version control, stuff like that, which can get very complicated. And that is looking at the advantages and disadvantages of FID versus FIT clients, looking at the client-server model, and also the advantages and disadvantages both with the languages that they use.